Welcome once again to my YouTube channel, Pearson and Excel International Maths, and subscribe and let us work together. Now that we have learned how to expand binomials using the Pascal's triangle, and we have also introduced ourselves to factorial notation, NCR, and so on, it is important that we learn how to use the factorial notation so that we can do away with Pascal's triangle, because you realize if you are expected to expand something to do with a plus b raised to power 5, because a binomial expression has two terms, and the binomial expansions allow you to expand powers of binomial expressions. And for example, if you have something like this, then this is to mean a plus b multiplied by itself 5 times, a plus b, a plus b, a plus b, and that is it. You realize that it's going to take a lot of time if you're expected to open up this bracket using the normal method we learned in year 11 of the FOIL. Multiplying all these terms out is going to take a lot of time, and again you are likely to make a few mistakes here and there, so your answer more often than not is not going to be accurate. So we have also introduced the Pascal's triangle, which is also very good, but you realize that you have to make the power increase for the first term and decrease for the second term. And then after you have done that, you bring in the coefficients like we have done in a few examples before. In factorial notation, that rule of the first term starting with the highest power and decreasing, and the second term starting with the lowest power and increasing, still holds. But the only difference is that in the factorial notation, you do not need to introduce the coefficients later. You walk hand in hand even as you bring in the coefficients, because this one is going to be, for example, the first coefficient of this expansion is going to be 5c0, which is basically 1, a raised to power 5, b raised to power 0. You realize that as you develop, as you gain knowledge in this particular part, you don't need to keep bringing 5c0 because that is obviously 1, and you don't need to bring in b raised to power 0 because that is also 1. So you may avoid that in future, but for now the second term is 5c1 a raised to power 4, the power reduces. Now b is the one with power 1, plus 5c2, that is now the coefficient. This is what is going to give you the coefficient, a raised to power 3, b raised to power 2. The other one is 5c3, a raised to power 2, b raised to power 3. And the other one, this is the coefficient now. The other one is 5c2, a raised to power 1, b4. And the other one is 0, 1, 2, 3, 4. This is 4. The other one is 0, 1, 2, 3, 4. And 5c5, a raised to power 0, b raised to power 5. All these are giving us coefficients. You could also write them in terms of, you could write them 5, 0, a raised to power 5, b raised to power 0, plus 5, 1. It's also very much acceptable. A4, b1, plus 5, 2, a3, b2, plus 5, 3. This is just because there are some calculators with this notion, a2, b3, plus 5, 4, A1 B4 plus 5 5 A0 B5. It's one of the same thing. This and this is simply one of the same thing. This and this is simply one of the same thing. And I want now to get to example 4 and use this method. And in example 4 we are told x, or rather use, this is example 4, use binomial theorem. This is now the binomial theorem to find the expansion of 3 minus 2x raised to power 5. And I directly go to the operations, and I start with the very first one, 5c0 of what? The first term with the highest power, 3 raised to power 5, and the second term with the lowest power, 0, plus 5c1 of the first term with one less the highest power, power 4, minus 2x power 1. Now the second term starts increasing in power, and of course this goes without saying, plus 5c 2 3 minus 2x 2 plus 5c3 3 2 minus 2x 3 plus 5c4 3 1 minus 2x 4, and finally plus 5c5 3 1 3 0 rather minus 2x 5. You may put this into bracket, those ones, to avoid looking at this like a decimal point. You may put the brackets, those ones. You may come up with brackets. You may consider them to be brackets. That way you will be safe. All we need to do is go to the calculator. 5c0 is obviously 1. 1 times 3 raised to power 5 times 3 raised to power 5. You get it is 243. And because this is 1, so the first term itself is 243. That is the first term. Go to the second term, 5c1. 5c1 is obviously 5. 5 times 3 raised to power 4, which is that, of course, minus times negative 2. You're going to get negative 810 because there is this negative 2. So you're going to have negative 810x. Go to the third one, and the third one is talking of let me line them up here. The third one is talking of what? 5c2, which is equals to what? 10. The coefficient is 10. Times 3 cubed, which is 27, times 27, yes, 270, times 4, because minus 2 squared is 4, times 4, giving us 1080 and positive, and there is x squared. So plus 1080 x squared. Go to the fourth term, which is talking of 5c3, c3, which is 10. That is 10 times 9. 3 squared is 9 times 9, times minus 8 times negative 8, because minus 2 squared is negative 8. It's going to be minus 720, and there is x cubed. So minus 720 x cubed. Go to this fifth term. We have 5c4. The coefficient is 5 times 3 because 3 raised to power 1 is 3. That is 15 times 16, because minus 2 raised to power 4 is 16. So times 16, you get 240, which is positive, plus 240 x raised to power 4. Go to the last one, which is 5c5. Go to the last one, which is 5c5, which is obviously 1. Again, this is the very last coefficient, times 1, because 3 raised to power 0 is 1. Of course, times minus 32, because minus 2 raised to power 5 is 32. Times minus 32, we are going to get negative 32, and we have x raised to power 5. So minus 32 x raised to power 5. And that is just what we have understood. Yes, it looks clumsy and overwhelming, but the moment you get used to it, at this level, most of you will still prefer the Pascal's triangle, but with time, you will prefer this approach. And that is just the end of the story. As far as example 4 is concerned, let us be on the lookout for example 5. All right, once again, go to my YouTube channel, subscribe, and let us work together. All right.